quadratic functions and transformations. As you go through this video, if it's going too fast, feel free to pause it and take whatever notes you need to. You'll see quadratic functions in everyday life. They're the things that make the shape of a parabola, that natural U shape. In Algebra 1, you learned a lot about linear functions, y equals x, y equals 2x plus 3. But in Algebra 2, we're going to start right off with quadratics. The graph of a quadratic function is a parabola. The basic equation for a quadratic function is y equals x squared. There's usually a bottom or a top to a parabola. That's called the vertex. The line up and down through the middle that you could draw that cuts a parabola exactly in half is the line of symmetry. To graph a function that has a coefficient like y equals ax squared using 1/2 for a, first off you want to graph a dot where the vertex is. If you plug in 0 for x, you would get 0 for y, so 0, 0. Then draw a vertical line through that vertex. That's your axis of symmetry. Then if you make yourself an xy table and put in nice numbers for x like 0, 1, 2 or 0, 2, 4, you can substitute those numbers in and calculate the y values and graph those dots. Since a parabola is symmetrical, those dots can be transferred across the line of symmetry and plotted on the other side without having to do any math. And then to finish off your graph, all you have to do is draw a nice smooth curve through the dots and you're done. This is a great spot to pause the video and take a few notes. Reflections. If you want to reflect anything across a y-axis, all you do is change the sign of the x. In this case, if we reflect a parabola across a y-axis, it lands on top of itself, so it looks like nothing really happened. To reflect across the x-axis, you change the sign of the y, or they put a negative in front of f of x. This is going to reflect over the x-axis, and it looks like it flips it upside down. So anytime there's a negative coefficient in x squared, it's an upside down parabola. If you multiply x squared by a coefficient, it's either going to stretch or compress the parabola. If the a number is greater than 1, then it stretches it or pulls the parabola up. If it's less than 1, it compresses it and pushes it down. To translate a parabola up or down, all you have to do is add or subtract a number to the x squared. If you add a number, it goes up. Subtract a number, it goes down. To translate it left or right, you do a similar thing. You add or subtract the x, but inside of the parentheses before the squared. But this one is backwards. Minus a number and moves right, so x minus 5 in parentheses squared moves right 5, and the opposite for left. This is a really quick example. You're going to have to pause the video here and take note of what happened and try and understand it. The vertex form of a quadratic function. Jot this one down in your notes. Key variables are a, h, and k. That tells you everything about the quadratic function. Also here, pause the video and copy this down. If you know the vertex of a parabola and one other point on the parabola, you can find the equation for that function. All you have to do is take the vertex numbers and plug them in for h and k into the vertex formula, and take the other number that's not the vertex and plug those two numbers into the x and y in the formula. Just be careful that the vertex goes into h and k, and the other two numbers are x and y. Once you do that, all you have to do is solve for a. 8 minus 5 is 3, 3 squared is 9, keep going, and you get a equals negative 5 over 9. Now you know a, h, and k, substitute those values into the formula, and you have the quadratic function. There are 5 problems for you to do for homework. Feel free to pause the video so you can copy these down real quick. Please do these as neat as you can on graph paper. Thanks.
created using Powtoon.